Hello, welcome. Let's try to solve another Leetcode problem. 1028. Recover a tree from preorder traversal. So first, let's try to understand the problem. So we run preorder depth first search of the root of a binary tree. So at each node in the traversal, we output d depth. So d is just a number. It means the depth of this node. Then we output the value of this node. So we're going to have a traversal string, and this string is going to be something like dashes value and dashes value, and we need to count how many dashes and how many value, and there's meaning for this dashes and the value. So let's just try to understand it. Yeah. So if the depth of the node is d, so the depth of its immediate child is d plus 1. Yeah. So according to the question, the root node, the depth is going to be 0. And the next node, this depth is going to be 1. And for this node 5, the depth is 1. And for node 3, the depth is 2. And for node 4, 6, and 7, the depth is 2. So if a node has only one child, that child is guaranteed to be the left child. So this means if we only have a node 1 and 2, so this node 2 must be the left child. So given the output traversal of this traversal, so we're going to recover the tree and return its root. So finally, we just need to return this root 1. Yeah. Now let's just check this string. Definitely, we want to find some property about the string, and then maybe we're going to use some data structure to solve the problem. So of course, this is going to be a binary tree problem, and let's just check the property of the string. Maybe we can find some important information from it. Maybe we can solve it. So from the beginning, there's no dash. This means from the beginning, this one gonna be a root node. And then after that, there's one dash. And after the dash, it's gonna be a number 2. So if it is something like that, it means it will go to the next level. So the level gonna plus 1. But we don't know it is left or right. But according to the question, let's just check from here. So if a node has only one child, so the child is guaranteed to be the left child. So from here, we are sure that after this node 1, we have a child with node 2 at the next level. Yeah. So we are not sure after 2 there's other string or not. But if there's only a 2, definitely this 2 is going to be the left child. And also according to the preorder traversal, first of all, it's going to be the root. After the root, it's going to be the left child. So this 2 is going to be the left child. So after that 2, we are not sure if there will be a node will go to the right side or it will continue at the left side. But let's just check. So we have 2 dashes and we have a value 3. This means for this node 3, it will go to the next level. So if it goes to the next level, we just ignore what after this node 3. So this node 3 must be at the left side of this node 2. According to the information about this question. Yeah, just ignore what is the value after that, because this is basically preorder traversal. First of all, we're going to go to the left, and then we're going to go to the first of all, we're going to go to the root, and then we go to the left, and then we go to the right. So this is the preorder traversal. Now we just ignore the 4, 5, 6, and 7. So for 1, 2, 3, it is okay, because for 1 there's a 0 dash, and for 2 it has 1 dash, and for 3 it has 2 dash. So it will just continue. And now what is after this node 3? It has 2 dash. So this means it's going to be in the same level. But we are not sure if this 4 can be the next level. Definitely it is not, because there are only 2 dash. So the depth is going to be 2. Otherwise, it's going to be 3. So currently it is 2. It means this node 4 cannot be the left side of node 3. It must be from somewhere else, but we are not sure. Yeah. But now we are sure that the depth of this node 4 is 2. So where we can find a depth with this node 4 can become 2. Only we can put it at the right side of this node 2, and in this way it's going to be the depth for this node 4 going to be 2. Otherwise, if you put this node 4 after node 1, so the depth is 1. It is not like the 2 dashes, so the depth should be 2. If it is a 2, definitely it's going to be here after the node 2, it's going to be the right child. So this is how can we understand the problem. Yeah. Now let's just continue. So now after finishing this 2, we're going to go to this 5. Yeah. So for this 5, how many dashes? Before 5, there's only one dash. Definitely it is not after 4, because after 4, no matter it is the left or right, the depth must be 3, but currently the depth is 1. So it means this 5 must be the right child of this node 1, because for this node 1, the depth is only 1. Now let's just continue. So for this node 6, before that there are 2 dashes. Yeah. So this means those 2 dashes must belong to the right branch, because we've already finished those 3 and 4, we've already finished. So this is like the iterative way of solving it with by using a stack. So I'm just talking about the simulation about it. Yeah, and it is also similar like the DFS part. We're gonna first go to the root node, and then we go to the left, and then we go to the right. So currently we've already go to the right side. Yeah, we've already have this node 5. Now we're gonna go to 6. So for this node 6, because the depth is 2, so here the depth 1, here the depth 2. First of all, it will go to the left side, so this is gonna be the node 6. And then we have 2 dashes, and it's gonna be the same level. Otherwise, if we have 3 dashes, so the 7 gonna be here. Yeah, but we have 2 dashes, it means the 7 must be the right child of this node 5. Yeah, so this is the entire simulation of the problem. But we're gonna use a stack to solve the problem, because stack would be much easier. Now let's just write this kind of method to solve the problem. So I'm gonna prepare a stack. I'm gonna prepare a position I, and I'm gonna prepare n, gonna be the length of the traversal. So empty stack with a 0 index and the length of the traversal. Now I'm gonna check 1 by 1. So for I less than n, I'm gonna check the character 1 by 1. So I have 2 code. So for one code, I'm gonna call it level, or I gonna call it depth. I think both ways would be okay. So let's just call it level. So level gonna be 0. So for another one is I gonna call a value. So the value gonna be the node's value, because I don't know whether it is 1, 2, or it is a 12. I don't know what it is, but I'm gonna prepare a value as 0. Now after that, I'm gonna prepare the node, because from the beginning it must be a tree node, and it must have a value of this value. So for example, for the first node, the value gonna be 1, and for this for the second example, the node gonna be 1, and for the third example, the node gonna be 1 as well. But there are also other numbers like 401. So we just need to accumulate the value and accumulate the level, and this one should be easy. And also for the value and the level, it should be easy to calculate. We just use a while loop, but I will write it later. So we just focus on the main part of the problem. Yeah, so if we can get the node, so the hard part is about how can we check if it will go to the left side or if it will go to the right side. We are not sure. So we're going to use this kind of check. So if the length of the stack equal to the level, this means that definitely it will go to the left side. So according to the simulation, definitely it will go to the left side. So from the beginning, the stack is empty, so the length is 0, and for the level from the beginning, it is also 0. So this means I need to put a node 1 inside the stack. Yeah, so let me just put it 1 inside the stack, but I will put it here. So the stack gonna append a node. Yeah. So from here, from the left side, if I were to put some node at the left side of this node 1, definitely it must have something inside the stack. So after we put 1 inside, so for this line of code, we just put node 1 inside. Now we're going to continue to check this node 2. As the length of the stack already become 1, and the level already become 1, so I need to put this node 2 at the left side of this node 1. So I need to have a check. So if there's something inside the stack, so the stack, the last child on top of the stack with -1 dot left gonna equal to this node. So this is the idea. Else, so for this node 3, I will continue to put it at the left side of this node 2, and then I will continue to check this node 4. But for this node 4, currently the level gonna become 2, and let me check the length of the stack. So the length of the stack gonna be 3 because we've already put 1, 2, and 3 nodes inside the stack. They are not equal. So this means this node 4 should be we should put at the right side of this node 2. Yeah. So first of all, we're gonna cut the stack. So the stack gonna cut it as level. So from the level, so we're gonna keep it from the level. So this means inside the stack, instead of 1, 2, 3, it's gonna be just 1 and 2, and then we're gonna put the right side, put this node 4 at the right side of this node 2. Yeah. So the stack minus 1 dot right. So it's right side gonna be this node. Yeah. So this is actually gonna be the entire code for the solution. So finally, we just need to return a stack 0. Yeah. This is actually the main part. Now we just need to calculate this level and the value. It's gonna be easier. Let's just use a while loop to check the level. So while I less than n, and let's check the traversal I equal to dash. So we're gonna update the I, and we're gonna update the level. And similarly for the value, let me just copy it. So for the value, we can update it together. So for this kind of code, it just means we're gonna check a dash with a number. We're gonna check a dash with number together. Yeah. For each of the time, we have to check the how many dashes and what is the number. And after that, we're gonna do the stack operation. Yeah. Let me just check the value. So if I less than n and traversal I, it is a number. So we're gonna use as a digit. So if it is as a digit, so I gonna plus equal to 1, and let's update the value. So it's gonna be 10 times the value plus integer of this traversal I. Yeah. So for example, we just turn this number. Maybe there's a 401. We just make it 401. Now I think it should be okay for the problem. Let me just run it. Did I do something wrong? I have a dash. Normally I shouldn't have no dash. Let me check it. I think the I should be after that. I should, first of all, I need to update the I, and then my I gonna plus 1. And similarly for here, otherwise I believe I'm gonna make a mistake. Yeah, so first of all, for the level, I'm gonna update a level, and then I gonna plus 1, and then I'm gonna check the while loop. And similarly for the value, first of all, I'm gonna update the value with this I, and then I plus 1, I'm gonna check the next number. Yeah, so I think this one should be okay this time. So the list index go out of the range. So the stack go out of the range. So the stack minus 1 dot right. Let me check. So this is the left side. If I have a stack, so the stack minus 1 dot left gonna equal to this node. Else stack will be cut to stack to the level. Yeah, I think I need to print out what is inside the stack. Why it is wrong? Let me just print it from here. So inside of the stack, I have this node 1. And next, if the length of the stack equal to the level, yeah, let me just check it from here. Yeah, let me use align as 21. So for here, I have an empty array. It should be okay. Yeah, because for the next time, I need to put this node 2 inside. But this stack, the length of the stack should equal to the level. But I go to the else. That means there's something wrong with my code. Yeah, let me just check what is the length of the stack and what is the level. Maybe there's something wrong with the level. So first of all, it is 0, 0, and then the length of the stack is 21. Let me just update it with line 20. It's going to be 22. Yeah, so for the line 20, first of all, I'm going to have a 0, 0, and then I should have 1 and 1, but I have a 1, 0. I think the yeah, the length of the stack should equal to the level, but my level I didn't update the level. Let me check what is wrong. Yeah, I think this is wrong. It should be a dash. That is why I just type a dash. It should be a hyphen. Now let me check. Now it seems it works. Yeah, now let me just delete those print and check if it can pass for all testing cases. You know, sometimes you're gonna make mistakes and you never know what's gonna happen. You have to check it carefully. You know, when I type a dash, definitely it's gonna be wrong because there's no dash. It is always yeah, like the sign dash. It's not the word dash. Now let me just submit it to check if it can pass. Yeah, as you can see, it passed for all testing cases and it's pretty fast because the time complexity is O(n) and the space complexity is O(n). Because whenever we use a stack, definitely the time complexity is going to be O(n). So n is 1000. That is why it's so fast. I think that's all for it. Thank you for watching. See you next time.